Hi, welcome to LeetCode. In this we discuss LeetCode problem 3453. Separate squares 1. So you are given a 2D integer array squares. Each squares I represent xi, yi, li. So it represents the coordinates of the bottom left point and the side length of a square parallel to the x-axis. So suppose we have given 0, 1, 2. So this means suppose we have a coordinate. So this is 0, 0 and this is actually x coordinate of y and this is x coordinate of minus infinity, right? Now what actually I can do, this represent that we have actually one point at point 0, 1. So this is 0, 1, right? 0, 1, and there is a square parallel to x-axis. So this is the parallel to x-axis, okay? So this is square. So this is starting point 0, 1. So the length is, side length will be here actually 2. So this point will be 0, not 2 plus 0 plus 2, 1. So this is ultimately 2, 1. And this point will represent, this length will be also same 2. This side length will also be 2 because this is a square. So this point will be, so this represents the bottom left point, bottom left 0, 1, and the length is, the length of the square is 2, okay, right? So you can actually find out all the other 3 points of this square, right? Now the next statement is that find the minimum y coordinate value of a horizontal line such that the total area of the squares above the line equals to the total area of the squares below the line. So we have written the suppose this is the our coordinates. So we have suppose 2, this is one square, this is another square, okay. Now suppose here actually length is 2, here length is 2, here length is 2, okay, here actually it is 2, 2, 2. So in this our squares input array we actually have 2 squares, okay. Now what actually I have to do, we have to find out some y, like suppose this is the y, suppose this is our y value, okay. So they want that like the total area above this line, what are the squares I have, the total area above this line, total area, suppose this is area 1 and this below the line of this y line is area 2. So this area 1 and area 2 should be equal, right? So now, so they note that squares may overlap, overlapping area should be counted multiple times. So suppose there is another square, this is another square, okay. So this area should be counted multiple times. So you do not have to think about the overlapping area, right? So procedure is clear. Now go to the example 1. So example 1 is, so this is the 0, 0, 1, 0, 0, 1. So first, so one point will be 0, 0, this is 0, 0. Another point will be, this is as a square. So square for square the length will be equal. So the length will be equal. So this is square. So the length here actually is 1. Here length is also 1. Here also length is 1. This is also 1. So this is 0, 0. So other 3 point will be 1, 0. This will be 1, 1, and this will be 1, 0. Right? 4 point we actually have got it. Now what I have to do? Another square actually I have 2, 2, 1. 2, 2, 1. So this will be 2, 2. This is 1, 1. So this will be suppose 2, 2. 2, 2. This is, so this square will be this. So the here actually 2, 2, and this is the side line is again 1. So this is 1, this is 1, this is 1. So the point here it will be 3, 2. This will be 3, 3, and this will be 2, 3, right? Now we have to find out one y value. Suppose this is the y value, that will be our answer. This is our y value, such that the square that is present in this below this line, the total area of this, it will be equal to the square that is present above this line. The total area should be both area 1 and area 2 will be equal. Now suppose this is our answer. Suppose here actually this is our the y value, y line. So I'll check that this square is below this line. Yes. How can you check that? So I'll check that the topmost y value it can, the square actually I have. This is the top edge. So this y value is 1. So this is, suppose y value is 2. Okay. So 1.5. So 1.5. So what will happen? This is the top value of the top top edge. So this is below this line. So I will count this area 1. This is area 2. So area 1 will be, what will be the area of this? This area will be 1 into 1. So total area for area 1 is 1. And for area 2, this is the above this line, y is equal to 1.5. So that area for this also is 1 into 1. This is 1. So both are actually equal. So this is one possible answer, one possible y value. Now what do they want? They want that we have to minimize the y value, minimum y coordinate value. So what are the brute force approach? You can actually think about this. So the range of the coordinate value will be start from 0 to 10 to the power 9. 10 to the power 9. Okay. So brute force approach will be what? I will check each y. I will check that y is equal to 0. Then if I actually divide this the squares on with respect to this line, then I will check what is the area 1 and then area 2. Then actually I will compare this actually equal or not. If it is equal, then this will be your answer. Alright. Now what will be the time series for this? I have to check each coordinate. So here actually for each coordinate, like for each position, I will check. So here the time will be of n, and I have to iterate each square that actually I have. So that will be again m if there are m square. So the times will be n into m, m into n. Got it? So this will give us a TLE, right? So what actually I can do? Here actually you can use the binary search logic. How? So we have to minimize the y. We have to find the minimum y value. So I'll start, like we will have one left pointer and another will be right pointer. So it will start from 0 and maximum it can go to 10 to the power 9. Right? This is L and this is R. So what will do? I will suppose find out one mid here. So I'll check that if I use this as a y coordinate, coordinate of the y line, then what will be the actually area 1 and what will be the area 2, right? So this will actually first suppose I got this, okay, this is actually not equal. So area 1 is actually greater than area 2, suppose. So then I have to actually shift this mid to that left side or right side on hot condition. If suppose this is actually suppose this is our the y length, y first. Suppose this is our mid. This is our mid. So what I have to first have to do? I will check what is the area below this line. Okay. So this is suppose area 1. Then what will be the area 2? This will be actually total area that actually I have minus a1. Total area actually I have actually total square. So if I actually subtract this a1, then I actually get the actually above a2. Right? This is clear. a2. This is actually above the line. Now we check that if this is actually, if a1 is equal to a2, then actually this is one possible answer. Then what I have to do? I will actually shift this right pointer to this mid minus 1. I will shift this right. I have to minimize this. If our area 1 is greater than a2, then what I have to do? Because that means our area that is below this line, that actually greater. So what I have to do? I have to shift this line, then actually this will decrease the area. Maybe possible that this will decrease the area of the square that is present below this line. If we shift this y coordinate to this below the previous value, right? Then this will actually increase the probability to decrease the area of the area 1, right? Else, if it is area 1 is less than a2, then I have to actually shift this y line to this towards upward. This will be then our upward, because this area actually less than this. Suppose this is actually a2 and this is a1. Whatever this line actually I have. So if a1 is less than a2, then what I have to do? I have to increase the a1 and decrease the a2. How we actually do that? If I shift this line to the upward, then actually what will do, this may possible that more square will be present in the below this line, and less number actually square will be present at the above this line, right? Got it? Got the logic? This is actually the main logic, that how actually we can actually shift the left pointer and right pointer with respect to the area 1. Area 1 means the area that is the total number of area or total sum of the area that is present in the below this line. Got it? Now go to actually code. So first of all, find the right pointer. So, and also I have to find out the total area. So if I do the area 1, then actually I easily find out A2 will be total area minus A1. So that's why first calculate the total area. So I have taken maximum y. This is actually the rightmost maximum y value actually I have present in the squares array, and total length is the total array, total area. Okay, now actually iterating each squares. So I will find out the maximum y actually I can have. Maximum y actually what will be the maximum y? The bottom left y value, bottom left y value plus the length I. This will be the y value, correct? This will be the top edge value, y coordinate of the top edge. Now total the area for this current square will be what? The length into length, because this is a square, so the area will be all the edge length is same, so that's why x into x. So here actually square 2 represent the length, so this is length into length, and I'm also casting this into 1.0 because this is actually expecting a double type. Okay, so I am also adding this current area into this total area value variable. Okay, now what will be the left pointer? Left pointer will be 0, and the right pointer will be maximum y coordinate actually I have seen. Right, now initially we don't need to the answer here. Okay, so what I have to do, I will check. They mentioned that we have to find out answer within 10 to the minus 5 range. So I will check that if it is r minus l value is greater than 10 to the minus 6, greater than. So still I have to still continue this our binary search. So I will get one mid value. Okay, so for current mid value, I will check this. What is the area actually I have in the below this y coordinate value, like below the mid. Okay, this is the current y. I am assuming this the mid value is the current y or one possible answer of the y line. Okay, so if the area at the present at the A1, this is actually A1 ultimately, current is represent the A1. So if this area is greater than the half means the area 1 is greater than the A2 ultimately. If A1 is greater than half, I have to ultimately what to do? I have to equalize the value, like means A1, the area 1, the below the line area and the above the line area. So area A1 is equal to A2. So if A1 means both are actually A1 plus A2 will be equal to total. So if both are equal, then 2A1 is equal to total, and A1 value will be total by 2. So if this A1 value is greater than equal to half means total area by half by 2, then what will be the I have to, if this is the line, assuming this is our answer, so this is actually A2 and this is A1. So if A1 is greater than A2, then what I have to do? This area actually greater than, so I have to shift this value to this below towards downside. So I will shift this to this list. So that's why what I have to do, I am shifting the right value to mid. Got it? Because our below the line area is really greater, so I have to shift this y value, so that will not, it will increase the probability of number of squares that is present above the line. Correct? Else means A1 is less than A2. Then what I have to do? I have here actually this area is less than, so I have to increase the area here A1. So I have to, if I shift this to the upward, then more number of squares will be present in this below the line. Got it? So that time I am shifting L pointer to this mid. Got it? And at the end return the R. What is the R actually I have? Now how actually calculating the number area that is below the line? So I will get one y coordinate value, that actually the reference line. So initially our area value is 0, and I am iterating each squares. Okay, so I will get one bottom y value and the one top y value, coordinate of the y maximum. So I'll check that if the top coordinate value of y is less than our reference point, then this is the completely below the line. So I'll actually calculate the area of the current square. So this will be actually the length into length, and this will be added to the area variable. Else, if our bottom is greater than equals to y, that means this is completely above the line. Alright. So what I will do, I will not count this into current area, because this is I am counting the area that is below the line. This is actually completely above the line, so I will just continue this. Else what will happen? Some portion is, it may possible, right? Some portion is, suppose this is a 1 square and our reference line is here. So what will be the area that is present below the line? So this will be the area. So this is the top, this is the bottom y value, and this is the top y value. So this is y2 suppose, and this is y1. So what I will do, I will find out this length. So this length will be what? Y minus y1. This will give the y minus y1. This is the y, and this length will be y minus 1, and length will be same. This length will be same. This is now a rectangle, right? Maybe rectangle. So the area for this area will be what? Length into y minus y1, right? So now I'm iterating the y value, new variable, that is the y reference point and the bottom value. Got it? This is the reference point y, and this is bottom value is y1. Got it? And now the area for this current square will be y and the length of this, because this is for x, this is constant, and ultimately return the area. This actually calculated the area that is present below the line, square that is below the line. Got it? With reference to this line y. Got it? In this actually we will calculate this. So this actually you can check that how actually what will be time sleep for this approach. So the range for this is 10 to the power 9, but actually we are using binary search, so this will be login. And for here actually I am helper function. This is the helper function. Here actually I am iterating each squares. So if the square's length is still m, squares number of squares is actually m, and range will be log n. So this will be m log n. Got it? This is clear. From n squared to n log n. So I have shared this code in the description. You can actually take the reference. And thank you. If you like the explanation, if it is clear for you, then please like the video. If any doubt, any suggestion, actually comment on that also. And if you're not yet subscribed, please subscribe the channel. Thank you.